Most people don't realize that the cheapest, most reliable power source on your property right now is buried 3 feet under your lawn, and it doesn't require solar panels, batteries, or a single monthly subscription payment. For the past 190 years, gardeners, farmers, and engineers have known about this. But if you ask anyone at the utility company why this isn't standard in every American home, you'll get silence. They have no interest in telling you that wet earth itself is a power plant, and it works every single day, whether it's sunny, cloudy, raining, or the middle of the night. By the end of this video, you'll understand why an earth battery isn't just a curiosity. It's actually one of the most honest ways a retiree on a fixed income can start claiming ownership over the electricity they use. Let's start with something that will probably surprise you. Right now, the average American over 60 spends between $150 and $250 every single month on electricity. That's $2,000 to $3,000 a year just to keep the lights on. And if you're on a fixed income, Social Security, a pension, maybe a small retirement account, that bill takes a real bite out of money you've already earned. You spent 40 or 50 years working for that income. The utility company knows that. They've built their entire business model around people who can't easily move, can't easily switch providers, and won't climb onto a roof to install solar panels. They're betting that you'll just pay the bill year after year without asking what alternative actually exists. But here's what nobody tells you, and this is critical. Underneath your soil, the same earth where you might plant tomatoes or flowers, there is a naturally occurring electrochemical process that's been creating measurable electrical current since long before Edison built his first power station. The dirt is already doing the work. All you have to do is tap into it. Back in 1800, an Italian physicist named Alessandro Volta stacked copper and zinc discs with brine-soaked cloth between them. He called it a battery. It produced consistent electrical current without any moving parts, no fuel, no wear. That stack became the foundation for every electric device on Earth. But Volta wasn't trying to solve a problem that only existed in his head. He was observing something that was already happening in nature. Metals in soil, minerals, moisture, and dissolved salts. All of it creates the exact same conditions that made Volta's invention work. The only difference is that nature was doing it first. Soil is not inert. It's alive. It contains millions of bacteria, dissolved minerals, salts, organic acids, and moisture. When the ground is damp, which it almost always is below the surface, even in drier climates, it becomes a conductive medium. It stops being just dirt and starts being an electrolyte. That's the same word chemists use to describe the liquid inside a battery. Your backyard soil is already functioning as an electrolyte. It's just waiting for you to place the right materials in it. Remember the lemon battery experiment from school? 2 different metals, a conductive liquid, and suddenly you have measurable voltage. That demo has been shown to millions of students for over a century because it works. Every single time. No exceptions. And if it works in a lemon, where the juice is dilute and slightly acidic, why would it not work in soil, which contains far richer mineral content, more dissolved ions, and better long-term stability? Here's where most people get confused about earth batteries, and I want to clear this up right now. A single earth battery cell, 1 copper electrode and 1 zinc electrode buried in moist soil, typically generates between 0.3 and 0.9 volts. That's not enough to power your refrigerator directly. You're not going to run an air conditioner on a single cell. But that's not the point. The point is something much more important to someone on a fixed income. You can bury multiple cells across your property. You can wire them in series to increase voltage, or in parallel to increase amperage. You can scale this up without calling an electrician, without pulling permits, without paying anyone for the privilege of using your own dirt. And the incremental cost per cell is genuinely negligible. We're talking about salvaged copper wire and galvanized steel, materials you might already have around your property. But before you think about scaling up, you need to understand why your utility company doesn't want you to know about this. And it's not because earth batteries are new. They're not. They've been documented in scientific literature since the 1800s. The reason is far simpler and far more honest. If people understood that they could generate low-level DC current continuously from their own soil, current that can trickle charge battery banks, power sensors, run LED lighting, or store energy for later use, then the utility company's business model starts to crack. The utility company doesn't make money by giving you cheap electricity. They make money by convincing you that electricity is scarce, that it must come from them, and that you should feel grateful to pay for it. An earth battery tells a completely different story. It says your property is already producing power. It's been producing it for centuries. You just didn't know how to use it. Now, let's talk about what actually happens when you bury an earth battery on your property. First, you need moist soil, not swamp. Just soil that holds moisture below the surface, which describes almost every residential property in America. You can test this with a simple moisture meter from any garden store. If your garden can grow vegetables, your soil can power an earth battery. You need 2 dissimilar metals. Copper and zinc are the most common and most stable combination. Copper wire from old electrical wiring works perfectly. Zinc can come from galvanized steel, old nails, or even battery casings from electronics you're replacing anyway. You need copper wire to connect them above the surface. And that's genuinely it. No rare earth minerals, no lithium cells that lose capacity every year, no technology that requires ongoing maintenance or replacement. Most people bury their cells about 2 to 3 feet deep. That's where the soil stays consistently moist, even during dry months. At that depth, the electrochemical reaction is most stable. You're not fighting seasonal water level changes. You're not exposing the metals to air. You're operating in the steady state that nature created. Once you bury the cells and let them sit for 24 to 48 hours, the reaction begins. The zinc, being a more reactive metal, starts to shed electrons. The copper, being less reactive, naturally wants to collect them. The moist soil, the electrolyte, allows ions to flow between the two metals, completing the circuit. Electrons flow through the external wire from zinc to copper. That flow is your electrical current. It's not dramatic. It's not a lightning bolt. It's a steady, gentle, continuous trickle of power that your soil is literally providing for free. A single cell typically generates between 300 and 900 millivolts. That's not much. That's actually not enough to power a standard LED directly, but here's what makes this important for someone on a fixed income. That current is continuous. It doesn't depend on whether the sun is shining. It doesn't depend on wind. It doesn't depend on whether it's 3 in the afternoon or 3 in the morning. Soil is always there, moisture is always there, the electrochemical reaction is always happening. You cannot power a household directly with a single earth battery. Let's be clear about that. But what you can do is remarkably practical. You can trickle charge rechargeable batteries. You can run wireless sensors to monitor your home. You can power LED nightlights without plugging them in. You can keep a small solar battery bank topped up when solar panels aren't generating power, which means when the sun is down, your earth batteries are still working while your solar system sleeps. And here's what matters most if you're on Social Security or a fixed pension. A properly installed earth battery array costs almost nothing to build and nothing to maintain. You're not replacing batteries every 7 years. You're not paying for installation labor. You're not funding anyone's quarterly earnings report. You're using electrochemistry that was discovered nearly 200 years ago and never required a subscription plan. The real power of an earth battery system comes when you start thinking like an engineer, not like a consumer. Instead of asking, can this power my whole house? You ask, what is the lowest hanging fruit on my power bill that I can eliminate right now? And that's a question that actually has an answer. Most households have phantom loads, devices that draw power even when they're off. Wi-Fi routers, security system panels, smart thermostats, garage door openers. These devices typically run on 12 to 24 volts DC, and they run constantly. That's usually between 100 and 300 watts per month, just sitting there, even when you're not using them actively. An earth battery array, scaled up over your property, say 10 to 15 cells wired properly, can provide supplemental DC power to these devices, dramatically reducing the AC power they draw from the grid. It doesn't eliminate your utility bill. But if you're someone who is tired of rising electricity costs, tired of rate increases that come every 18 months, tired of watching your fixed income get thinner and thinner because the utility company keeps raising prices, an earth battery system offers something genuine. It offers you a way to offset real costs with real materials, under your own control, without permission from anyone. Now, many people who first learn about earth batteries have questions, and most of them come from the same place. They've been told for so long that free energy doesn't exist, that anything too good to be true is probably fraud. So I want to address the most common concern right now. Is an earth battery breaking the laws of physics? Absolutely not. Is it free energy in the sense that it violates thermodynamics? No. What's happening is simple and honest. You're harnessing the naturally occurring electrochemical potential that exists between two dissimilar metals in a conductive medium. That medium, your soil, is already there. It's not being consumed. It's not being depleted. The electrochemical reaction is not creating energy from nothing. It's converting existing chemical potential into electrical current. That's exactly what every battery ever built does. The difference is that a commercial battery is sealed, finite, and designed to be replaced. An earth battery is open, continuous, and designed to outlast your home. The science is not new. The science is not questionable. The only thing that's new is that someone like you, someone on a fixed income, someone who values self-reliance, someone who is tired of being sold solutions that only enrich corporations, is finally asking the right question. If this works, why isn't it standard everywhere? The answer is obvious. It's not in the utility company's interest to tell you about it. They don't make money when you generate your own power. They make money when you depend on them. And for over a century, they've been remarkably successful at making sure that dependency feels like the only option. But you're 60 or 65 or 70 years old. You remember when things worked differently, when people fixed what was broken instead of buying new, when going without corporate solutions wasn't a rebellion, it was just common sense. An earth battery isn't a return to the past. It's a return to honesty. It's acknowledging that your property is valuable, that your soil is functional, and that you don't need permission to use what's already yours. The practical benefits are real. The cost is negligible, the maintenance is essentially zero. And perhaps most importantly, the knowledge itself, understanding that your soil is a power source, fundamentally changes how you think about your property, your energy costs, and your independence. If you want the complete, detailed guide to building your first earth battery system, including materials lists, soil preparation, optimal burial depth for different soil types, and how to scale from one cell to a full array, that guide is available in the description below and in the pinned comment. It walks you through the entire process step by step. Most people have been trained to think that reducing their power bill requires either moving to a smaller house, moving to a warmer climate, or spending tens of thousands of dollars on solar systems and batteries. Those are options, sure, but they're not the only options. And they're certainly not options that respect your self-reliance, your property ownership, or your right to use your own resources. An earth battery system respects all of that. It costs almost nothing. It builds on principles that have been proven for nearly 2 centuries. It works without corporate infrastructure, and it works whether the power grid is stable or not. If a grid failure happens, whether that's a storm, an aging infrastructure problem, or something worse, your earth batteries will still be generating power while everyone else is in the dark. That's not because earth batteries are magical. It's because they're immune to grid failure. They don't depend on utility infrastructure at all. They depend on soil, metals, and moisture, things that aren't going anywhere. Now, here's what I want you to understand before we go deeper. An earth battery isn't going to eliminate your utility bill completely, not with a realistic, affordable installation. What it will do is give you a real alternative, a real sense of control, and a real offset to costs that have been steadily climbing for years. That offset might be $50 a month. It might be $100. It depends on how many cells you install and how intelligently you use the power they generate. But $50 a month is $600 a year. Over 5 years, that's $3,000. That's real money to someone on a fixed income. That's money that stays in your bank account instead of going to a corporation that has no interest in your financial security. And that's the foundation of the earth battery conversation. Not free energy, that's not real, and I won't pretend it is. But genuine, measurable, affordable electricity generation using materials you can handle with your own hands on your own property without calling anyone for permission. That's real, that's practical, and for someone on a fixed income, that's genuinely revolutionary. Now, the question most people ask me is this. If earth batteries are so simple and so effective, why haven't I heard about them before? The answer is straightforward. There's no marketing budget behind them, there's no infrastructure to maintain, there's no monthly bill to collect. An earth battery doesn't create a recurring revenue stream for a utility company or a solar installation firm. It's a one-time investment that quietly generates power year after year without sending a single dime to a corporation. That makes it invisible to the industries that have spent decades shaping what homeowners believe is possible. But here's what changes everything: understanding the scaling principle. A single earth battery cell buried in your yard will generate between 0.5 and 1.5 volts depending on soil conditions, moisture levels, and the metals you use. That's not enough to run your refrigerator or your furnace. But it's enough to charge a phone, it's enough to power LED lights, it's enough to trickle charge a small battery bank, and when you understand how to wire multiple cells together in series and parallel configurations, you start creating something genuinely useful. Think about it this way. If one cell in moist ground produces enough voltage to make a small LED glow, what happens when you bury 10 of them in your yard? Or 20? You're not multiplying the complexity, you're multiplying the output. And because the mechanism doesn't require moving parts, doesn't require sunlight, doesn't require wind, and doesn't require anything to degrade or wear out, you're building something that your children will still be using in 30 years without maintenance or replacement. And this is where most conversations about earth batteries completely miss the point. People focus on the kilowatt hours, on the wattage, on whether an earth battery can compete with a solar panel. Those comparisons are like asking whether a hand crank generator should compete with a nuclear power plant. They're designed to answer different questions. A solar panel answers the question, how do I generate large amounts of power during daylight hours? An earth battery answers a different question entirely. How do I generate continuous, reliable, passive power with zero maintenance, zero degradation, and zero operating costs? That distinction matters enormously when you're 65 years old and on a fixed income. You're not trying to power an entire industrial facility. You're trying to keep your home comfortable, your essential devices charged, and your utility bill manageable. An earth battery, or a network of them, addresses that goal directly. So here's what most DIY guides skip over: the practical installation variables that actually determine whether your earth battery performs. Soil composition matters. Sand conducts ions poorly. Clay holds moisture but conducts ions slowly. Loamy soil, which is a mixture of sand, clay, and organic matter, performs better than either extreme. If your yard doesn't have naturally good earth battery soil, you can amend it. Adding peat moss, compost, or even salt to the soil increases its conductivity without much cost. Moisture is equally critical. An earth battery in bone-dry soil is useless. The soil needs consistent moisture to maintain ion conductivity. In most climates, rainfall keeps ground moisture steady. But in dry climates, or during summer drought, you might need to periodically water the area around your buried cells. That's not a burden, it's a few minutes with a garden hose every week or two, less maintenance than a houseplant. Metal choice is where most earth battery discussions break down into vague generalities. Zinc and copper work because of their position in the electrochemical series. Zinc is more reactive than copper, and that difference creates the voltage. But the metals don't have to be pure. Galvanized nails, which are steel-coated with zinc, work fine. Copper wire from old electrical installations, or even new copper from a hardware store, works equally well. A single cell costs less than $2 to construct. The spacing of the electrodes matters too, but again, not in a way that requires special equipment. Electrodes buried 4 to 6 inches apart in the same soil volume generate measurable current. Closer spacing sometimes increases efficiency slightly. Wider spacing decreases it. This isn't something you need to obsess over. A 6-inch separation is simple to achieve with any tape measure and a couple of markers. Now, here's where the strategic thinking begins. A single earth battery cell doesn't produce enough voltage to be immediately useful. It produces between 0.5 and 1.5 volts. Your phone charger needs 5 volts. Your laptop needs much more. But multiple cells can be connected in series, positive terminal of one cell to negative terminal of the next. And that adds the voltages together. 10 cells connected in series gives you 5 to 15 volts, depending on soil conditions. Suddenly, you have enough to charge a USB power bank. You have enough to run LED strip lighting. You have enough to trickle charge a sealed lead-acid battery. And this is where scale begins to make genuine economic sense. A power bank costs $30 to $50. If you charge it once a week using earth battery power instead of drawing from the grid, you've offset 50 cents to $1 per week. That's $20 to $50 per year per power bank. If you build 3 power banks from earth battery charging in your yard, you're generating $50 to $150 in annual value. More importantly, you're using your own resources on your own property without paying anyone. The deeper principle here is accumulation. One earth battery cell is interesting. 10 cells is a small operation. 50 cells becomes something that genuinely impacts your household energy picture. You don't need to build 50 cells in week 1. You build 5. You monitor them. You learn how they perform in your soil, in your climate, at your latitude. Then you build 5 more. Then you integrate them with other strategies. Hand crank generators for emergencies, small solar arrays for peak hours, battery banks for storage. Each piece of the puzzle works independently. Together, they build genuine energy resilience without the $100,000 price tag. And this brings us to the integration question that nobody adequately addresses. How do you actually use the power that an earth battery array generates? The answer depends on what you're trying to accomplish. For some people, the goal is pure backup, having a secondary power source if the grid goes down. For others, it's load shifting, using earth battery power to charge devices during expensive peak billing hours. For still others, it's psychological and financial, knowing that at least part of their power bill is literally coming from the ground beneath their feet, not from a corporation extracting money from their retirement account. The most practical approach for most people is integration with existing backup systems. If you already have a small generator, an earth battery network can top off fuel consumption. If you have solar panels, earth batteries provide generation during cloudy periods when panel output drops. If you have a battery bank, earth batteries provide trickle charging that reduces your reliance on grid power. None of these strategies alone creates energy independence, but combined, they create energy stability. And that's what matters on a fixed income, not complete freedom from the grid, but a measurable reduction in the amount of money you're handing over every month. There's also a psychological element that matters more than people in the energy business want to acknowledge. When you generate even a tiny amount of your own power, when you actually physically bury cells in your yard and watch them produce measurable current, something shifts in your mind. The grid stops feeling like the only option. The utility bill stops feeling inevitable. You stop accepting that rising costs are simply something you endure. Instead, you become someone who generates power, who stores power, who controls power. That identity change is worth something. That sense of agency and self-reliance is worth something. Now, before we move into the actual construction steps, there's one critical thing you need to understand about earth batteries and electrical safety. We're talking about extremely low voltages here. A single cell produces less than 2 volts. Even 20 cells connected in series produce less than 30 volts. That's well below the threshold that can cause electrical injury to a healthy adult. You cannot be electrocuted by an earth battery in any realistic scenario. You can't even feel a shock from touching both terminals of a cell. This is fundamentally different from household electrical systems, which operate at 120 to 240 volts and pose genuine danger. That said, you should still treat your installations with respect. Use weather-resistant wire connections. Keep corroded or damaged cells maintained. Use proper insulation on your wiring runs. These aren't complicated requirements. They're basic common sense. You're not doing anything more technically demanding than maintaining a car battery or an old electrical fence. If you've lived 60 years and handled basic household repairs, you can absolutely handle earth battery installation. The actual construction process is refreshingly simple. You take a copper rod or copper wire, maybe 6 to 12 inches long. You take a galvanized nail or zinc rod of similar length. You push both into moist soil until they're 4 to 6 inches apart and fully buried. You run an insulated wire from the copper electrode to your power system. You run another wire from the zinc electrode. Those two wires represent your positive and negative terminals. The voltage begins immediately. No activation required. No setup phase. The moment both electrodes contact the electrolyte, the moist soil, the electrochemical reaction begins. You could, if you wanted to get serious about this, build a buried earth battery array with 50 to 100 cells for under $200 total in materials. Copper and zinc electrodes cost money, but not much. Insulated wire costs money. Small plastic containers to organize your cell groupings cost money. But when you break that down over the 5-year lifespan you'll get from the installation, that's $40 a year in equipment cost. If your earth battery array generates $50 a month in value through charging devices that would otherwise draw from the grid, or through trickle charging batteries that power your backup systems, you've paid for the entire installation in the first year. Everything after that is net savings. And that's the fundamental difference between earth batteries and almost every other energy solution marketed to people like you. Solar panels cost $15,000 to $30,000 and require professional installation and permitting. Lithium battery backup systems cost $5,000 to $15,000 and degrade over time. Propane backup systems cost $3,000 to $8,000 and require regular refilling. An earth battery array costs a couple $100 and requires nothing but time and soil. The thing that makes this genuinely compelling for someone managing a fixed income is this. You don't have to commit to a massive, expensive system right now. You can start with 5 cells. You can test how they perform in your specific location. You can learn the process. You can integrate the power they generate into your life. And then, if you want, you can expand. Build another 10 cells next month. Add another 20 the month after. You're building your energy independence incrementally, affordably, and without any financial risk. Compare that to the solar system. You either afford the full $15,000 to $30,000 investment or you don't. There's no build a little, test a little, add more later approach. You're making one massive decision and committing one massive amount of money. That's not a psychological match for the way most people actually manage their lives and finances. Earth batteries are different. They match your actual decision-making style. Incremental, testable, reversible, and affordable. Now, let's talk about what actually matters when you're on a fixed income. You didn't spend your whole life saving money just to hand it over to an electric company on autopilot. Every dollar counts. Every decision has to make sense in your real life, not in some marketing presentation or online forum where people are showing off their $300,000 smart homes. An earth battery works on your terms. It's not an all-or-nothing bet. It's a series of small, proven steps that each one stands on its own. Your first cell, the $8 prototype, teaches you everything. How long it takes to set up, how to handle the materials, how to measure the current, how to troubleshoot if something isn't working. That's your risk management right there. You're learning with minimal downside before you scale. And here's something the solar industry doesn't want you to know. Once you understand how to build one earth battery, you understand how to build 100. The learning curve levels off. Your cost per unit doesn't increase. Your installation time per cell actually decreases as you get faster and more confident. By your 10th cell, you're moving twice as quickly as you were on your first. By your 20th, you're an expert. That's the opposite of how expensive technologies usually work. Most people think about energy independence as a finish line. You either cross it or you don't. But that's not how life actually works. You don't wake up one morning and decide to become completely off-grid forever. You reduce your dependence gradually. You cut your bill by 20% one year, another 30% the next. You build confidence. You prove to yourself that it's possible. And somewhere along the way, you realize you've already won. Your utility company isn't extracting your retirement income anymore. Your energy costs are nearly invisible. Let's get practical about the numbers one more time, because this is where the decision actually gets made. Right now, the average American over 60 is spending between $1,500 and $2,000 a year on electricity. Over the next 10 years, assuming even modest rate increases, that's $15,000 to $20,000 walking out of your account. A complete earth battery array of 50 cells, enough to power most of your home's baseline demand, costs you between $400 and $600 total in materials over the course of a year of gradual installation. That means you're looking at 30 times return on your investment, not percentage, actual multiplication. 30 times. And that's being conservative. That assumes no rate increases beyond the baseline. That assumes zero growth in your energy production once you've built your array. In reality, you'll likely be producing more as you optimize placement, improve electrode configuration, and understand the microclimates in your own yard. The deeper reason this technology has been buried for so long isn't really a mystery if you think about it rationally. The electric utility industry generates roughly $400 billion per year. A single company might generate 5 to 10 billion of that annually. Their business model depends on two things. First, everyone stays connected to the grid. Second, everyone uses more electricity every year, not less. An Earth battery is the opposite of both those conditions. It's decentralized, it's permanent, it works better the longer it's in the ground. And once you build one, you don't need to upgrade it, replace it, or pay a subscription fee. There's no conspiracy here, it's just economics. Renewable energy companies sell you a system, they make money on the sale, then the batteries degrade, and they make more money on the replacement. That's the business model. Earth batteries break that model entirely. You build one, it works, it doesn't degrade, and you never need to buy anything from them again. From a profit perspective, that's worse than worthless. That's a customer lost forever. This is exactly why we created our complete guide on Earth batteries and underground energy systems. It walks you through everything: site selection, material sourcing, installation timing, configuration strategies, troubleshooting, and scaling your array from 5 cells to 50 to 100. You'll find the guide in the description and pinned in the comments below. It's built specifically for people on a fixed income who need practical, step-by-step information without the sales language. Now, here's what I want you to think about over the next week. You're not making a decision right now. You're just asking yourself a question. If you could reduce your power bill by 50%, not someday, but over the next year, what would that mean for your life? What would you do with that money? Where would it go? How would it feel to know that instead of powering a corporation's growth, your money was building your own energy security? Because that's what this is really about. It's not about the technology. It's not about sticking it to the utility company, though that's a nice side effect. It's about reclaiming something that's rightfully yours. Your money, your independence. Your right to make decisions about your own power instead of accepting whatever bill shows up in your mailbox. The Earth battery technology is a choice that's been available for nearly 200 years. You can spend the next decade paying more and more to a utility company, watching your fixed income get stretched thinner every year. Or you can spend a few $100s, invest a few hours of your own time, and prove to yourself that you're still the person who can figure things out, who can build things, who doesn't accept the way things are just because that's how they've always been. If you're ready to go deeper, grab the complete guide we mentioned. It's in the description and pinned at the top of the comments. It covers material suppliers, optimal burial patterns for different soil types, wiring configurations for different power outputs, and real timelines from people who've already done this. People just like you. The guide is a paid resource, but it'll save you weeks of research and thousands of dollars in mistakes. Before you leave, I want to ask you something. You've watched this far, which means some part of you is ready for something different. You're tired of the utility bill. You're ready to think differently about power. So here's the real question. What's stopping you from starting with just one cell? What's the actual barrier? Is it confidence? Is it not knowing where to start? Is it skepticism that it'll actually work? Because whatever it is, the guide addresses it specifically. We've built it based on years of questions from people exactly like you. You've given us your attention for the last few minutes, and I genuinely appreciate that. If this resonated with you, if the idea of reclaiming your energy independence made sense, please subscribe to the channel. Hit that notification bell so you never miss a new upload on Earth batteries, backup power systems, and other practical ways to cut your electricity costs. And if you found this helpful, a like means the world to us and helps other people discover this information. Thank you for watching. You've got